Kia ora, and welcome to the Master of Aerospace Engineering webinar at the University of Auckland. I'm Professor G. Aglietti, I'm the Director of the Space Institute, and I'm also the Director of the Master Program. My background is in aerospace engineering. I have been here at the university for the past 6 years, and for the previous 25 years I was working in the UK, all the time across between university and industry, to make sure that the two institutions work together, and in particular the research and education that we do at the university is really synchronized with what goes on in the real world, let's say. I'm here with two students, former student of ours and a current student, that will help to discuss this one. Perhaps if you can briefly introduce yourself.
Hi, I am Daniel. I finished my Master of Aerospace Engineering degree with G about roughly a year ago, and I work as a research and development engineer for Fisher & Paykel Healthcare, as well as I also run my own astronaut organization for education purposes.
Hi, I'm Jordan. I did my undergraduate degree in engineering at the University of Auckland, specialising in engineering science, and then I'm currently studying a Masters of Aerospace Engineering at the University of Auckland.
Okay, thank you for the brief introduction. Essentially, the structure of this webinar is quite simple, and we will discuss the structure of the course, and then we will hear a bit more from our students about their particular experience and how this course has really helped them to join sort of the workforce. If we want to start talking about who is the master for, and essentially our target student is someone that has done its first degree into a more generic discipline, let's say engineering or science, and really now wants to join the aerospace sector. So this is exactly what the master has been designed for. And essentially, if we want to talk about the structure of the program and the duration, concerning the duration is either 1 year or 1 year and a half, and the students can choose if they want to do the research path or if they want to do the taught path. And if they prefer the research path, essentially a large part of their work is going to be a research project. This research project takes about 3/4 of the year. They have the opportunity to work often with an expert from industry on a topic that has got both academic relevance and also some industrial interest. And vice versa, the students that are choosing to do the taught version have a smaller research project that essentially can be done in less than a semester, and will do more courses, taught courses, where they cover a lot of the disciplines that are really part of the broader field of the aerospace engineering. And I would say that what makes our master really distinctive is the applied nature, the fact that we are working all the time with industry, that the kind of research that we do all the time is tailored about solving specific problems. Sometimes it's a bit of an utilitarian view of kind of the world, but ultimately we want to make a real progress. We want to provide impact with our research, so it's important that we work on real issue, and the fact that we are doing a lot of the projects in partnership with industry really bridges the gap between the traditional academic education and what goes on in the real world in industry. So if we want to really prepare our students for jobs in the space sector, it's really important that we have this kind of co-supervised projects. And ultimately, once they finish our master program and they decide what they want to do in their future, well, we have a vast group of, maybe slightly less than 50% that continue in a research type of career. Sometimes they want to stay in a university type of environment. They carry on doing PhDs, really getting postdoc position, this kind of work. In other cases, they really want to sort of join the workforce, and we feel that the kind of preparation that we have given us, in particular through the projects, is really helping them to find jobs, again, with the companies, sometimes the same companies that were partners in the projects that they have done. So it becomes almost a seamless transition between what they have done with us at the university and what they will be doing with these companies. So sometimes they are like an ideal candidate because they are already aware of the kind of issue a particular company is working on, the particular technologies. So about the delivery of the master program, We run our master from the city campus here at the University of Auckland in the CBD. And we actually recruit students twice a year, in the summer and in the winter. So it's useful for both people that come from the Northern Hemisphere and the Southern Hemisphere. And we offer also scholarships that can help students. The details about the scholarships are available online. So if you are interested, you can look at our website where you'll find all the information, because they tend to change from year after year. So you can find the latest and up-to-date information on the website. Now, if our students can help, again, to discuss a bit more about the course and their experience. So maybe we can start from seeing, how this master program has really built on your previous experience of your first degree. Has it really helped to build on what you already knew and give you more information? Please.
So I did my undergrad in mechanical engineering at the University of Auckland, and then I straight went on to doing a master in aerospace, and I felt like it is very well linked between the mechanical and aerospace. The master degree then gave me a much broader view of what the aerospace industry is doing, some of the standard practice that happens there, as well as it made me a lot more confident in tackling complex projects at a system level, with all that exposure from this particular master program. And yeah, and we also got some great exposure to some very talented experts within the industry that always basically help us grow in a continuous manner.
Yeah, so I think the master's is really good because it builds on all the skills you learn in your undergrad. So I think in the undergrad you learn like maths, you learn the design skills, you learn the software skills, but I think it can feel like quite disjointed at times because the skills are quite separate, whereas I think the master's program really gives you the opportunity to take all these skills and put them into like one year-long project that you sort of manage yourself from start to finish. And I think in particular, this master's program has given me really good access to industry experts and academic experts. So with Professor G and then another industry supervisor, I've been able to really learn from their expertise and develop my own design project. And I think even my industry supervisor has said a few times, this is what I've learned. You wouldn't be able to find this online, but this is what I recommend. And so I think getting that expertise is really unique to the University of Auckland and this specific master's program.
Yeah, well, thank you for your kind words anyway. But essentially, if you can tell us something about, why did you choose this Master of Aerospace Engineering, and particularly at the University of Auckland?
I have always sort of been interested in sort of the space sector and the aerospace industry, but I think it's really hard to sort of know what's actually going on in these sectors. I think if you look it up online, you don't really understand what it actually means to work in the space industry. And so I think the Masters of Aerospace Engineering really appealed to me to sort of learn about the industry and get exposure to those topics. And I was also fortunate enough to be awarded a research master scholarship. So that's why I chose University of Auckland, because it covered my fees and gave me a stipend to do it. And so yeah, it was really appealing to me.
I actually did a smaller research project with Professor G as an undergrad. So before then, I didn't even know the Space Institute existed. And I felt like the project was a very good balance between academia, sort of theoretical research, as well as practical applications of something we're trying to achieve in the round of space and aerodynamics, etc. So that was a fantastic opportunity for me, and then that really got me into it. So once I got to know what projects there were at the Space Institute, it was a fairly easy decision to then go I really want to do this because some very exciting projects going on, and I felt like I can learn a lot from the structure here.
When you decided to do the master, can you tell us, did you have any hesitation with your decision? What were you thinking about?
I think when you finish your undergraduate degree, there's a world of opportunities that you can pursue. You can go into working full time, you can do a PhD, you can do a master's, you can take a gap year. So I think there's always a lot of things you need to weigh up. For me, I think some of my main hesitancy was working. I know lots of my friends from my undergraduate degree, went into the workforce, and I sort of thought they're going to be making this money and I'm going to be doing a master's, but I think having the qualification is something that really gets you in the door of companies. And I really want to go overseas, especially working in Europe. And so in Europe, it's really, really vital to have a master's in engineering to do really technical jobs. And so I think that really motivated me to do it. So I sort of weighed up, the money versus the qualifications. And I thought at the end of the day, it's 1 year of, lost income versus a whole lifetime where like the degree can be really useful and really get you in the door in like a competitive area. And so that's how I sort of balanced the hesitancy and made my decision to do the master's.
Yeah, no, very, very, very good. And from your perspective?
So first, space is obviously interesting, very exciting as well. But also, when I started thinking about it, it appeared to me like this little niche, tiny little field that's just tucked away under all these large engineering branches. But so yeah, had a bit of hesitation in whether just how big the industry is, or whether it's just a tiny little industry that doesn't have much of growth. However, that was then the illusion of the reality. So after I got to know more about what the space industry is actually doing, and literally how rapid and how fast it's expanding and growing over the past few years or so, and then how it's continued to grow, producing various new opportunity in both the technology as well as the commercial environment, then that really convinced me to pursue this degree and then weigh up the opportunity versus like cost and time commitment, that kind of thing. So that rubbed away the hesitation pretty fast once you got to know the industry a bit more.
Yeah, no, very good. And perhaps just a clarification that although, again, Daniel has worked particularly in the sort of space sector, but the master cover actually the whole of the aerospace. So we have on one side space type of technologies, satellites, rockets, and so on, but also all aircraft, aerodynamic, propulsion, and so on. So it's a much broader degrees, but the students can choose if they want to work on the space technology side, or if they prefer aircraft, that kind of things. So essentially, there are also students that specialize in those sort of areas, whereas again, the students that we have here prefer to specialize on the space side of our broader degree. But essentially what you were saying before, that doing a master, you sort of spend another year in education while you could have joined the workforce and already starts earning, but that is again offset by the rest of your career where you enter with higher qualifications, and so hopefully you can progress much more quickly and to higher positions than if you didn't have this sort of second degree. Jordan, can you tell us more about the specific details of your project? What have you been studying?
Yes, so I've been looking into reaction wheels. So reaction wheels are a component on satellites that control the attitude and orientation of the satellite. So they're like very mission critical. And in particular, I've been trying to improve the demisability of satellites. So there's a big issue at the moment where satellites have to come back down to Earth after a certain number of years. And they want to do this sort of that they come down naturally over time. But in order to do that, there needs to be a low casualty risk. So a low risk of satellites coming down to Earth and sort of falling down in massive chunks of metal. And so there's a lot of interest and a lot of research being done currently into trying to make satellites demise, so burn up in the atmosphere, so that they can be allowed to come down. And typically reaction wheels are made up of, they're big stainless steel discs, so they really don't burn up very well in the atmosphere. So I've been trying to design a hollow flywheel for a reaction wheel that is filled with powder, so that it's got a thin outer shell and burns up easier in the atmosphere, with a dense powder inside to make up a heavy moment of inertia.
Thank you, very interesting. And again, as you can see, there is a practical problem that has to be solved, but there is also the academic component, making a model of this kind of technologies. And then again, the proof of the pudding is also doing experimentations. So Jordan is also in the lab to try to build this thing and see, making sure that really works. Daniel, can you tell us something about, what your project was about, its relevance, let's say, for industry, for example?
Yeah, so it's called a self-deployable for you baffle. So basically we took the inspiration from a very special type of spring and then allowed the light shield outside of a camera to become deployable, meaning you can then shrink it down in size, put it into a compact volume, put that on the rocket launch so it doesn't occupy as much volume. And then once you get up there in orbit, then you can allow the structure to pop out and extend back into the length that it intends to be, and then therefore function. And then basically shields away excess light so your camera doesn't get blinded by the sun or another bright object flying next to your satellite. So that helps with satellite imagery, that kind of area. So fairly practical use as well.
Again, yeah, so all the projects that we want to do really merge a kind of usefulness, a real problem that we want to solve, working often with a company that has identified the need to improve that particular technology or to solve that particular issue. And clearly, I've got also the academic component, theoretical component. So we try to cover the whole range, starting from the concept to the practicalities, then to, again, a proof of concept to see that really what the students are proposing is going to work for real. And these are usually things that are very appreciated in the industrial world. Employers really like this thing that their education goes beyond their traditional academic approach of, let's say, like the theoretical world, but they can really see how the theory then is applied to practice and resolve a real issue, and then ultimately helps their companies. And essentially, in particular to you, Dan, how the master really has helped you academically and professionally to join, let's say, like the sector, the workforce.
This is something really beneficial that you can take these fundamental principles about how do you problem solve and tackle complex projects with a lot of unknowns in them and actually come to a great solution that is well validated and well proven and ready to go. So that's really valuable in a generic sense. And in a specialization sense, this is a very unique program that gives me a lot of both knowledge and experience in space sector in particular to me. And also I'm sure it gave a lot of aerodynamics related specialties to other students. And for me, that is great exposure to a group of really talented people and able to learn from them about how does the space industry work and then just how rapidly it's growing. What are some of the great work that has been done here? What are some of the standards, very high standards that we do things in aerospace engineering? And that basically opened up this whole entire new field of career that which I'm able to look into. It's opening up new opportunities for students like me that was never going to be available.
Daniel, can you tell us something about how the employers have valued your qualification with the Master of Aerospace Engineering?
Yeah, sure, certainly. So after the training of Master of Aerospace Engineering, I felt like I've become a lot more confident in tackling almost like a little independent project that someone or higher management can hand over to me. And now I am capable of then breaking that down, taking that from requirements to some specifications, and then breaking it down to executable chunks of little steps and increments that we're able to figure out and also deliver a solution, almost like a little package. And with that training there, that system level thinking as well as the experience in tackling research project during the masters really helped in that sense, and it made me become a more valuable employee and less of a hassle for the management to then sort of micromanage every step and then kind of have to guide you through everything. So it then really helped in my career.
Okay, thank you. So you think that this skill that you have learned with a master to really manage your work has been really something that the employers have really appreciated then? Maybe we can also talk about things beyond maybe the really just the study, but your life. You have a lot of different things that are going on and you have to balance, studying the academic, courses, exams and so on, with all the other things that are going on in your life. I don't know, maybe you're doing sports and things like that. Can you tell us about, maybe again, starting with you, how you manage to balance all these things in your life?
Yeah, so I think it's really helpful to balance your life, especially when you're doing a research master's, because it's a sort of self-led project. So you sort of have the opportunity to set your own working hours, do what's best for you. So you're really able to have that flexibility to work part-time if you need to, or, do family commitments. I think it's really like a unique time in your life where you can sort of manage your own schedule compared to maybe having a full-time job where you're like in set hours. And the university also really offers support and flexibility. So if you need like extra time for personal circumstances, the university is really flexible in giving you that support. And your supervisors are really understanding and will help you get that extra time if you need, and they will like allow you to balance your commitments and stuff like that. Yeah.
Thank you. Daniel, from your point of view.
Yeah, again, firstly, I would definitely agree. So I also did a research master, and therefore 3/4 of the time is basically the research project, which allows a bit more flexibility than what you normally have in very concrete courses. And that allows me to then arrange time to complete certain tasks, and also to able to rearrange some of the work, time allocation, etc. And also we get a lot of good support from our supervisor. So part of the learning from structuring your research program is also time management. And our research supervisor doesn't only just help academically. That structured learning in terms of the time management and project management can also be very supportive in how do we then allocate our time outside of the academic world. So basically leading on to a fairly well-balanced sort of life and study and work relationship situation.
Yeah, it's great to hear that you managed again to balance all these different things without, going too much in one direction or another one. But again, now maybe Daniel, you can tell us about more how you think the master has really prepared you to push the boundaries of, let's say, like the technologies in this sector.
Yeah, certainly. First of all, as I mentioned, I didn't even know Space Institute existed before I started. I then started to consider this program quite seriously, and that really opened up a gateway into firstly understanding what the current space industry is doing. It's not quite like 50, 60 years ago. The technology has really moved on. There's been a lot of good work, a lot of engineer scientists that's been working in this area for a very long time. And basically, we are at an era where there's was a lot of prosperity in the growth of this industry. So firstly, having that exposure to that is very valuable to then just open my mind up to say, hey, there's actually a lot of exciting things going on here. And secondly is to basically give me exposure to a lot of really talented people around the globe that is working on towards a common goal, which is basically could be increase our understanding of the universe, etc., which is always very, very exciting.
As part of my master's, I got the opportunity to do an internship with the Space Institute. So I was called a satellite operations internship, and I got to have like a 12-week time period where I went in once a week and got lectures and training from industry professionals. So people that work in the mission planning side or in the orbital dynamics side. And so this gave me like real world experience into what actually goes into launching satellites and the running of satellites, which is something that I would never have got otherwise. And so I think getting these industry insights and learning from industry people really gave me an edge. So I'll be able to, be more competitive in the job market and really have a better understanding about what goes into sort of the satellite operations and launch side, so that I can really make like a positive contribution rather than sort of going into the workforce blind or without having that like insider knowledge. So yeah, I think that was really helpful for me.
Yeah, I really think that you are right. These connections with what is going on in the real world makes actually the education that we offer really, competitive and up to date, rather than just being the standard things that has been written in books, decades ago. And at the same time, again, when you join the workforce, you are immediately ready because you know what goes on, thanks to all these connections that we have all the time, in particular with the projects done, for example, in partnership with industry and so on. So again, I just wanted to thank you, both of you, for your contribution and for sharing with all of us, your experience. I'd like to thank the audience for participating to this webinar. So if you are interested, you can get in touch with the university. You can ask Auckland online. There is a link with the description in the description box. And again, thank you once again for attending this webinar.